Hey there. So, as I said, we're going to keep going with chapter 3, section 1, talking about some more derivatives. And we're going to be giving you one more derivative rule, and then we're going to look at some other applications of the power rule and the constant rules. So, our next rule here, so get yourself ready for notes. We're going to get started. Our next rule here is just specific to the function e to the x. So we use this a lot, if you remember, in pre-calc, talking about exponential growth. Now here's like this weird thing that's just true of e to the x. Its derivative is equal to itself. This is one of the reasons that e is kind of like a special number, like how pi is. It just shows up randomly in sort of the natural world. It's a very common irrational number, and it also has this very cool property that its derivative is the same as itself. Pretty easy. So when we see e to the x and we're being asked to differentiate, when we're being asked to find the derivative of, I realize I did not define that term in the last notes and I apologize. Differentiate f of x is equal to 2e to the x minus 4 root x. So when we do that, we, just like last time, are going to think about each term separately. So f prime of x, the derivative, would be d dx of 2e to the x minus d dx of 4. And I'm going to rewrite x root x, because I said this is going to be applying the power rule, as x to the 1/2. So remember, roots are always fractions. So if it was a cube root, it'd be to the 1/3. If it was the fifth root, it'd be to the 1/5, and so on. So I'm going to rewrite that so I can say this is x to the 1/2. And again, I'm going to keep writing out every single step separately. If you feel like you can start doing some steps in your head, I encourage that. I'm just fine with that. I will keep writing them out so that we are all on the same page. We'll take our constants, our coefficients, out in front. So this becomes 2 times the derivative of e to the x minus 4 times the derivative of x to the 1/2. So e to the x, as we've just said, this is always e to the x. It is equal to itself. So this is 2 e to the x minus, and here we have a power rule, even though it's a fraction, still works. That comes down, becomes the new coefficient, and then minus 1. So in this case, this becomes 4 times 1/2 x to the 1/2 minus 1, which is negative 1/2. Now, you can absolutely leave it as a negative 1/2 like this, but just as you might recall, this is also the same as 2e to the x minus, and I'm going to simplify our coefficients here, 4 times 1/2 is also 2. And then x to the negative 1/2 is also 1 over x to the positive 1/2, which you would also rewrite if you wanted to using the same rule that we had above. 2e to the x minus 2 multiplies into the numerator, x to the 1/2 is root x. You could rationalize that denominator if you like. So there's just some good algebra review that you might see, so it makes it easier to check your answers in the back of the book, because they might write it like this, they might write it as the radical form like that. So here, we don't have an e to the x, but we do have a very complicated fraction, and what we're always going to want to do with these problems first is simplify. And this has been true all the time. So simplify first. This will be a really important rule for a lot. There is, as you can imagine, what's called the quotient rule, which is a derivative rule when you have a quotient or a fraction. It's a super complicated formula. It's kind of like the quadratic formula where you try to get away with using it as little as possible. Like you'd rather factor, you'd rather simplify. Same thing here. One really helpful simplification rule for this type of problem is that if you have a fraction where you have a plus b over x, whatever the denominator is, you can break that up into a over x plus b over x. And this is nice for derivatives because you can then do those each separately instead of trying to simplify them as one big term. One thing is that you can absolutely do this in the numerator. If it was the other way around, you can't simplify. So just as a reminder, if you have x over a plus b, no simplifying there. That's as simple as it gets. So in this case, we're going to simplify first, and we're going to say f of x, we're not taking the derivative yet, is equal to the cube root of x squared over root x plus x root x over root x. So what I've done is I've taken the two terms of the numerator, separated them out. Hopefully right away you can see that we can do this, and we've got a nice simple x as our second term. In this case it's a little bit more complicated, but I'm going to turn them into powers. So this is x squared instead of cube root. It's to the power of 1/3. And then x is to the 1/2 for the root, plus x just from the second term. Now we end up with x squared, and when they're looking like this, remember we can multiply the exponents together. So this becomes x to the 2/3. And when they're in a fraction, so if I have a power in the numerator and a power in the denominator, I can subtract. So this becomes x to the 2/3 minus 1/2 plus x as our second term. 2/3 minus 1/2. Right, if you want to grab a calculator, you can. You can also just treat that like a regular subtraction problem. Make a common denominator. And we end up with x to the 4/6 minus 3/6. And so that's x to the 1/6 plus x as a simplified version of f of x. So then when I take the derivative, and I'm going to start just doing a couple of these by hand. Put the 1 there, take the power, move it down, minus 1, power, take it down, minus 1. So f prime is equal to 1/6 x to the 1/6 minus 1 plus 1 times x to the 1 minus 1. One thing that is nice about showing all your work is you want to make sure that this number and this number match before you subtract, right? So 1/6 and 1/6 are here, and then there's the subtraction. All right? Just a common mistake I see students making. So then f prime of x is equal to 1/6 x to the negative 5/6 plus 1. And again, you could turn that into a root and a fraction and everything, but it's just fine like that. Let me know if you have questions about e to the x or any of these derivatives of roots and radicals. Put things in the nomination form, set up a Zoom meeting, or leave something in the comments. I'll talk to you later.